Zillow, he is a returned econ speaker. Give it up for him. Redub.
So hello guys, this is me presenting again a new tool I have developed since the start of this year. Redub is literally a new dub I have been working. It's completely new code right now because I didn't really want to keep debugging dub. Its code was really complex, really messy for me. Sometimes when I'm pretty sure I'm working more from one side, I prefer having more control on the code. And this is, again, to solve a big problem in G I have been having since the start, building and configuring and iterating. So let's get this started. So I'll start here by comparing Redub with Reggie and Dub. They are mostly similar. As you can see, Dub can't do parallel compilation. Reggie does bake commands, but I think this is more of a feature to fight against what Dub does today because it doesn't do it really nicely. I have also global cache for Redub, which makes your folder less messy. Reggie has configuration freedom, which is a really nice thing, but I don't really like it when you're trying to deal with public key projects because sometimes people try to do configurations really different from other people, and actually this makes the environment more aggressive to new users. This also brings to the lack of focus on user experience that I didn't really like when using Reggie. Also, the good thing about Dub and Redub is that since it's backed by Decode for the compilation stuff, you can always improve it somehow. You don't need to deal with C code, which for me it's a big gain. And also it doesn't require other tools. Those are the projects I have been trying to support while doing Redub, mostly because they are the biggest projects available in the Dub registry. They were really not testing subjects for me because they were really hard to support without using Dub as a library. So when we start talking about Dub, like it just started with a big mess. This is a performance view for Hyperion engine run for the first time when in Dub. It needs to generate its log file. This takes like just a lot of time. It takes like 27 seconds against 1 second on Redub because Redub doesn't do any kind of log files. And also, it's really hard to debug what's happening on this side of Dub. I wasn't able to really understand how I could improve this part. When you're looking at what makes Dub really slow, you can see it's kind of disappointing because 70% of the time it's like parsing JSON files into an intermediate representation that can generate comments. And especially it's the DYAML, which is taking like most of the time in Dub, which really makes it take 300 milliseconds on up-to-date build checks, which is really bad. So when you compare to Redub, the call stack here is very shallow compared to Dub, and also the JSON loading takes like 1% of the time from the entire operation, which makes a complete difference. Beyond that, Redub is also using content hashing and caching, so it's able to do that in 28 milliseconds, which is like half than 1/10 of the time. So it's a great improvement on that side. As I said, I don't use log files. I'm not really fond of them. I think they make things more messy because people really depend on that. And I have understood that completely while developing Redub. People use Semver, but they don't really get how it works, both in the implementation and on the definition. Like people release hotfixes with breaking changes. So actually, if you don't have a log file, your program will much likely don't work because you need to use it correctly. The thing is that in the end, you're using log files because people don't really use correctly Semver. So it kind of kills the point. So not really something I really messed around. How I've improved over Dub was I tried to completely avoid state mutation. I didn't really like how Dub used classes to implement some things. You read its code, but you weren't able to understand what was happening on its backend. So I have used this functional style. It was my first time trying it. So only explicit evaluation is valid on this code. And also, I'm not completely against state mutation, especially because when you think about cache, it's all about state mutation. And that's why I use it, like caching JSON files. So whenever you have to parse a JSON file, it won't parse more than one time. Make it much faster also. And better JSON algorithm, it's pretty important for that one. My JSON is like 5 times faster than the ones being used on Dub, which makes a really big difference. I don't use intermediate representations because I wasn't even thinking about supporting more than one format. I think JSON is mostly enough for most projects. Maybe JSON improvement, like having comments on other things, but having more than one format just make open source projects harder to talk with each other. In the end, I don't think it brings much value. That's basically why. I also have done lazy parsing for Redub for parsing dependencies. That's really important because it would also fix the biggest problems I've saw in Dub. Like it would depend on package that aren't actually being used inside the current configuration. That was a pretty dumb bug. Beyond solving this bug, it also brings a better performance when you're trying to build, which is what I'm trying to achieve here. Beyond the performance improvement I tried to bring onto the table, I brought also the version recommendation. Like when your project fails to build, I always recommend a new version of Redub. This new version also can make people start failing to update their compiler or their build tool, which I have been seeing this much on Discord every time, like people using a 40 versions old DMD for something. Like, what's the solution? To just update, but they don't know they did to update. So this is one of the problems I try to solve. And also, you can list your dependencies by OS and compiler, just like being consistent with what the proposed in the beginning. This also brings more meaning to the have underline version it defines for every project. So I had to do this for every time when I tried running for my cross-platform programs. Like I would need to define that I'm using DirectX because Dub itself would not be enough for most of the cases. Also, one thing that one person on Discord shared with me is that the main thing to make your compilation faster and never slower is you always need to be aware of what is happening on your compilation times. This is very interesting because I have also fixed a potential problem I've almost done on Redub. I was developing Redub while building with Redub itself. After some updates, I've started to notice that it had become a little slower than I was trying to check what happened. And in the end was because I started using range algorithms. Unfortunately, they aren't very well suitable when you want to have more speed. It's like the classic speed and memory usage trade-off. So in the end, I've wanted to keep more for speed on that case. Also, it saves the meta information, so you can change your default compiler anytime if you wish. so it would not also parse every time the compiler version and information you need when you're building, because of, I think almost no one knows that, but whenever you use Dub, you can also say what versions of compiler are supported. So actually, Dub is always doing that and losing a little bit of performance on this, but this feature is not even used by most, so it's a kind of wasted effort. Also, the files in Redub aren't compiled again when you're just saving them, because it uses content hashing, which is a big problem I saw on Dub, especially if you would save like one of your leaf dependencies. It would take like just a lot of time building again. The development plan for Redub was basically starting small and just trying to bring parallelization for it. I didn't think about the JSON thing or anything in the beginning. I was just wanting to get things running fast as I could. So I would just keep running Dub on my project with the variables flag and trying to reverse engineer it without reading its code, because I didn't want to. I think I would actually lose more time trying to understand this code than the variables output. And also, of course, trying to find where it was slow, so I could tackle, and parallelize everything, so I could get to the meat part of this. With Redub, I've tried to avoid mostly rebuilding. This is why I wanted to do the global caching. I even thought about having like defined versions used in your project. This could be like a useful feature, because usually when you add a new version to the root project, the other leaves of your project need to rebuild. But actually, most of the time, you're not defining those versions to be used by your dependencies. But this is still an idea I'm holding for the future. The hashing algorithm, I'm using XXHash, which went in 3 times faster than MD5 in the practice. So this was a really big deal for me. Hashing check and calculation was really slow. One of the ways I've tried to make to solve this was trying to find idle places in my own code when I was running parallel. For example, I would calculate the hash of the project which just finished building while it's still running parallel, so it would not lose time. This was a big improvement also in the final product. And separate responsibility for packages. Like currently, this is all segregated on ADVDiff, which basically just holds states for folders and files. And also you can calculate difference status between projects. It will also output which files have actually changed. So this is really useful and also could be more of a tool to improve in the future. Now, when you compare build times between Dub, Redub, and Reg, for me, actually, Reg didn't even work for my engine. I don't know why. It's looking for a file in a folder that doesn't even exist. On Dub, you can see it takes almost 4 seconds. Redub takes almost 1 second full rebuild, which is a great improvement for me, especially. This is a great thing when you're developing core libraries or standard libraries, because it will mostly be imported by everything. And if you're still actively developing it, everything will must be rebuilt. It will take like a lot of time always rebuilding. Also, it's important to notice that this program is running a very fast PC and with many threads. I think on the PC I'm presenting today, it's like 6 times lower than that. And that can make a really difference when you're developing. For the root-only build, you can see it is 300 milliseconds faster than Dub. That's basically the time it takes to parse the JSON, because it's almost instantaneous on Redub. And for the Vibed, you can see Dub takes 11 seconds, Redub takes 3 seconds, and Reg plus Ninja can take 2.9 seconds and 3.3 seconds with literally the same time from Redub. I didn't really understand why Reg started going slower after I run Dub. Make Dub a virus and we should delete. But I don't really understand that. For the dub registry, which is a great project because it's really, really slow to build, I've tried with dub, it took 32 seconds. For redub, it took 8 seconds, and reggae, it was 11. But it's interesting to see why redub went so much faster. So this is a thing I've discovered while developing on Windows, is that basically the MSVC linker has always the incremental flag online. Actually, for D, this is making the build slower on Windows. So I'm using some strategies to disable this flag whenever you have too many projects inside your dub.json, so you can get a much faster linker time inside Windows. Maybe this explains why Windows Y was always lower than Linux for me when trying to build on the same PC. The main problem I've seen on Dub is that there's a lot of community division. There's a lot of people out there which doesn't use Dub, doesn't use Reggie, they just use the raw compiler. Mainly because when people start using Dub, they have lack of understanding how the decompiler works and how to organize their package. There's a lot of things that feel like just push it into Dub because people didn't really get what was the scope, so it's basically doing everything right now, even things that I find completely unnecessary, like having a main source file or even pre-generate commands. I have seen so many people using that wrongly. Separation compilation is doing more harm than good most of the time for those people using Dub. Dub as a library is also being heavily considered when taking a step into the future. The problem is that there's almost no project using Dub as a library, and beyond that, even Dub is not respecting the Semver itself. It's just releasing versions. They don't want to have breaking changes, even though you can just import an older version of it and adapt it whenever you need. Like, you just should not stop moving just because you're going to break. So it's quite different situation from the compiler itself. The compiler doesn't have versioning how Dub does. For people to understand what's making their compilation so slow, it's important to understand the semantic phases on the compiler, and it's also important to notice that those things I'm explaining here, it's all trial and error. I didn't really even read some of the compiler source code, but those are all practical results. And as you can see, in semantic phase 1 is basically about text parsing. And this is everything. Like, whenever you think about importing, you're bringing more text. Mixing templates, you also copy and paste more text in the same place you're using. It's really easy to optimize semantic 1 phase. And we'll show here how strategic usage can avoid other triggers of semantic passes. This is a Hello World program. All it does is printing Hello World. It takes 400 milliseconds to build, and that's just like a lot. The problem I've saw is that many people is using package.g, which like what import std is. This imports a lot of things that aren't necessary for your program, like core sys, Windows, even CURL inside this Hello World program. That's why if you're a library developer, this you should avoid all of the time. By simply changing to standard IO, you can already drop your compilation time to 140 milliseconds. Whenever you're aware of the compilation time, you can always go further than that. And how you could go even further than standard IO, it's by using standard C, standard UU. Now you've just dropped it to 12 milliseconds. Even though the implementation is very different, they achieve the same result. And sometimes when you're trying to optimize for compilation time, you need to understand that you may have to change your implementation, because sometimes things are like just trying to blast things with a rocket when you just needed a sword. So other thing here, mixing templates can make your compilation slower. You can see here, it's a very absurd example, but this actually happens when you use mixing templates on Dub. Whenever you need to have a mixing template being used and imported, all of the other files that import this one, they will have to reparse it again. And because you're doing this at separate compilation, your compilation will start to become very slow. Things like mixing templates should be completely avoided for packages that are actually imported by the user. They should be more internally owned. There's also the semantic 2, which is basically CTFE and default initializers from what I've saw. Unicode tables is the example you basically see for every D program. Most of the time, you don't have no bottlenecks on that. They are usually very obvious. This is one of the biggest semantic 2 phases I've seen. It's the UIG from Windows. I've seen so many people importing Core Sys Windows that also automatically imports this module. This takes 100 milliseconds, but I've seen PCs taking like 600, and this will be a big pain for your compilation performance when you're trying to do separate compilations. So I went into the packages and starting pull requesting to remove this import, so it would also fix my own project. Also, as you can see here, this is a function that only adds. We initialized that on CTFE. As you can see, it's clearly listed here how they affect your compilation time. It's not really hard to see that what's really causing this problem. You can just take a look on the graph. For the semantic tree, we have the template expansion, compile time reflection, metaprogramming, and also it's important to notice that semantic tree is always triggering a new semantic 1 and 2 pass, maybe even a third pass for the semantic tree. It's literally the worst thing you can do whenever you want to have a good compilation time. Oh yeah, and also function body evaluation, which is important to talk about that later. This is a template that generates tuples with types to the power of 3. There isn't even many types here, but of course power of 3 is too many. It takes 18 seconds to build that. It's also important to understand that this is pretty important. This compilation time completely relies on the implementation itself of the type you're generating. I've defined a new tuple here, which is like literally saying what are the fields there and the length. Whenever I tried with the standard tuple, the compiler actually would crash with how much time it would take. DMD without the code generation here takes 1.4 seconds, while with the code generation takes 16 seconds. So the code generation here is doing most of the penalty. So I even think people should be more aware with this in the future about the performance they are losing whenever they are using metaprogramming and how to improve them, like typeless code. The effect on compilation time is always shown for the semantic tree phase. Even inside the main function, you'll see this part is only evaluated inside the semantic tree. And if you recall, I was also using this on CTFE. So they are pretty different where they are running based where your code is positioned. Also, the relationship between compilation time and semantic tree code generation is almost linear, like 500 milliseconds for semantic tree and 500 milliseconds for code gen. But if I wrote more things inside this stack for it, it will basically take double the time or triple until you can have actually run the code. I will start here by showing how I optimized Hyperime engine for compilation time. It started taking by 3.7 seconds, and this is a picture on how it was before optimizing. It's pretty dense graph. Understanding to the semantic 1 problem is that CTFE actually retriggers inside separate compilation. So whenever you try to build with all at once, you actually would get a much faster build time than separate compilation. And that's happened because each library which is building must compile this CTFE. So you're not actually reusing that. This must happen every DMD pass. And since the asynchronous, you actually get this stall. To solve this, there are two simple ways to do it. You can do a runtime getter for this, like using static this for runtime initialization, and runtime getter. The separate compilation time is almost the same right now for the same project. Also, you get the same results, so you need to understand when you should be doing this. The other way to solve this, as I mentioned earlier, your module should be private. It should be internal and not imported by your user. And this is how you do it. You need to import this file which has the CTFE inside your function. By doing that, whenever your other module is importing this, it won't depend on the module that uses the CTFE, so your root module won't need to recalculate this function. You will still get the gains from having the CTFE being run, and also you don't get the toll of having separate compilation being hurt by that. By doing semantic one optimization, you can see the graph already starts to become really cleaner and easier to understand. In that stage, there is too much amount of optimization to do. For the semantic tree, it's important also to notice I've wrote here a function called open the pack. Why the pack? It's because it's including a lot of imports inside this function. If you clear this line, you actually won't import anything. Your build times will be much faster. So it's important to understand that just by moving your imports inside the functions, your compile time will start just getting much better. And you won't start getting those retriggers inside your module. By doing those optimizations, by simply moving the code inside the function, I was able to reduce the root module from 2.95 seconds to 1.9. This was almost 50% of the time, and for doing those optimizations, I didn't even take a day. So it's clearly a matter of priority for people when they are trying to do that. And also there's the separate compilation optimization. Whenever you add a new library to your root project, this library always takes more time. But there's a way for you to don't get lost with this time you've just added. We are trying to deal here with a case called Task Watcher. This Task Watcher will basically import FSWatch library in Dub, which use file watcher APIs from each operating system. We also want to include threads for non-blocking operation and queue system. The solution for that is that our API that is completely segregated, we should actually start doing a new library completely separate from the main program, even if you think it's very simple, especially because whenever you're importing a module that is not actually being used by the other modules, you actually lose this time every time you need to build your project, and this can make you lose like a lot of time. And this is an implementation. We'll look later on how we can improve that. It even has the optimization of not using package.g, which is a very obvious problem people usually does, but it's a very simple implementation here. As you can see here, by just putting your new class inside a new library and to import this library, you can just reduce your compilation time from 500 milliseconds to 162. All of the work on that was basically creating another folder, hitting dub init, adding to the dependency, and just importing the file just as you would do if it was in the main module. Whenever you're trying to look on the parallel compilation, the thing you must understand is that the slower your compilation is the same amount of time your slowest take. So it's important to have those small units so every rebuild will be faster than the most projects. So every unit matters whenever you're trying to use parallel compilation. The strategy here is basically moving the imports inside the function bodies. So as you can see on the top of the module, there isn't any import being used. Other thing I've done, which is like going a little bit further, is like using opaque types. They are necessary whenever you're trying to reduce import, especially from things that are quite heavy, like standard concurrency. And also, if you're doing private function implementations, you could like just move them inside another function. By moving your private implementation inside another function, you basically lose all the tolling those imports are doing. So it's a really great technique to improve your compilation time. And also, of course, whenever the main problem about using opaque times is that you need to cast it back. but that's mainly a problem to the library writer themselves than to the actual user. By applying those concepts, we have reduced our file watcher here to 12 milliseconds from 500. That's very impressive when you see, because your compilation time is now really, really fast, like the same from standard C, standard IO to Hello World programs, but you're actually running a file watcher. So that's by using all those techniques, you can make your program and library much better. By applying all of those concepts into Hyperime Engine, I was able to reduce the compilation time to 0.76. This is like 80% of the time from the graph I shown earlier. Every time I have a new bottleneck, it's much easier to understand where and what's happening. Whenever you want to sort your code, it's important to you start it earlier than later, especially because when the mess is starting to pile together, you start to lose track on what's happening. You need to be more cautious whenever you're trying to do it. On the future of the decompiler, I have been expecting the compiler as a library, especially because the compiler as a library would allow the compiler daemon, which could also interact with the build tools, like getting the diff status. The compiler would also store the template state information, which would finally solve the problem about separate object compilation inside D, which actually made it slower when I tried inside Redub or Reggie. A good idea, I thought it could be great, was the parallel generation inside the decompiler, especially because, as we saw on the semantic tree path there, most of the time we're spent on code generation whenever people started using metaprogramming tools. So that's very important things to keep in mind, I think. Parallel compilation inside the DMD, I don't think it's really important. Like storing the state right now and loading it back could bring a much better result in the end. On the future of Redub itself, I plan to start doing a new format beyond just compatibility, which will be redub.json. Also, plugins inside Redub could solve all of that. I'm still thinking about lock files generation, which I think they are really ugly. Also, Redub daemon, which could solve the file watcher stuff. About replacing Dub, I don't really care about it. I think there's problems about official releases that project starts to moving quite slow, and I'm not really fond of that idea. The future system, of course, it's a new system for defining dependencies between plugins, which will all be compiled and stored and cached for Redub, which also could solve the problem about people running bash commands or CMD commands inside the compilation. It also could store more information for making the compilation faster and more flexible. And this is the presentation. Show me your questions if you have.
Thanks for all the tips about reducing compilation times. I've dabbled with a few of those myself. Could you go back to the slide where you're comparing the build times between Reggie, Redub, and Dub? Was this all at once? So all the files?
It was just a clear Ninja run. I wasn't even running Reggie here for the generation.
Okay. Because that will, by default, build per package, not all at once and not per module. So the comparison should have been done probably like that. And then in one of your first slides, you were saying that there was the comparison and it was D only and no external dependencies. Reggie is only written in D and only depends on Dub. That's the only dependency it has.
Mm-hmm. Oh, yeah, I listened to that before, like using Ninja or Makefiles, which is an external dependency.
Right, but they're not required because it has its own backend too, in D.
Oh, yeah. That's one of the main problems I had when using Reg. The documentation wasn't really nice when trying to do it. I think it lacks more examples when using those things. That was really hard to.
Yeah, that's for sure. I'm terrible at writing documentation. So you said it wasn't very user friendly. It is if the user's me.
First of all, thanks a lot for working on improving the build performance. I think it's great. And my question is, you mentioned you don't do log files. Does this mean there's no way to make sure that you get the same version again when you rebuild it?
The way you do it is actually by locking the version yourself, like defining I want the version 1 of this specific dependency. This is basically what the lock file is actually doing. It's locking for you, but you're actually committing this. It's automatically generated, but that's basically how you do it right now.
I have a question about the content hashing. So you mentioned the XX hash. Is that a cryptographically safe hash, or is it just used to be used for safe hash tables?
Actually, it's used only for storing the information for everything.
So MDFM is more like in the range of used for persistent hashes. So Zcash, for instance, I don't recall if it uses MD5 or SHA-1, but it uses persistent caching, right? Does Redub does that, or is it planned to use persistent caching of the object artifacts?
Oh yeah, it uses caching on the artifacts itself, on the build configuration, the file state information, and all of that is always loaded back whenever I try to run from the second time.
So you're storing it to disk, is that what you're saying? Or is it just in-memory cache?
No, it's both in-memory cache and in file cache.
Okay, so the thing is, there is this new hash developed recently called Blake 3. I think you should look into it. It's meant to be used for basically have no chance of collisions. I think it's 10 times faster than MD5 and big files. So I think this is the ideal hash for these kinds of situations.
I think this idea could also be shared on the issues on Redub. I think it's a great thing to take a look. Unrelated to that, I have also taken a look on the fastest JSON parser we have on Dub, which is the ASDF. In the end, I was pretty surprised that it wasn't faster than the one I've done, but I take that my guess would be because the way ASDF JSON is parsed, it's not really well suited when you need generic data that can be accessed by the hashing. Whenever we are trying to take the step further for the performance related things, I think it's always important to test and profile them, because even then XX hash sold itself as almost fast as main copy, but on the practice it wasn't like that real, especially when you compare to MD5. Like MD5 was supposed to be really slow, so it's always important to profile them.
Thank you for excellent work, it looks like. I look forward to trying it out. You mentioned locking the compiler front-end version, which you say is not used very often. I didn't get, does Redub support it, or did it drop it?
No, actually it also supports and cache this information.
Right.
Actually, every time you run Dub, it actually executes like DMD-version and parses this. And that information is stored in a cached way inside Redub.
It will fail to compile if the front end doesn't match?
Yeah, if the version doesn't match to the required version specified the toolchain requirements inside Dub.json, then they don't really build it.
Yeah, I love that for a reproducible build.
You gave an example about the compilation speed difference of like including standard versus standard IO. Did you ever experiment with selective imports as well?
So selective imports is actually a hack inside the decompiler, which is basically doing aliases to symbols inside the selective import that you listed. The problem I have solved, I actually have done, does more harm than good whenever you're using it, especially inside classes, because it creates this symbol inside the class, and sometimes it can clash. The problem is not very clearly listed what is happening, so the selective import is actually not doing anything better than that.
Did you test the compilation speed?
Yeah, as I said, whenever you want to cache those types, it's more from a library developer side. Don't make the users do it themselves.
And the second question is configurations. So in Dub, you can have a library and you can have dependencies, but then you can also have different configurations. Maybe an external dependency is only pulled in during the unit test configuration, as an example. Does Redub basically snip out dependencies that are not used in the currently compiled configuration?
Basically, the problem is that Dub tries to parse everything And that's not what happens in the actual compilation itself. So I don't need to snip that out. I just don't need to parse everything. So it's a much smarter solution for solving this problem. Maybe Dub does that because it could a configuration depend on a different version of your dependency, but that doesn't really matter when you're trying to build another configuration. So that's why I just don't include this information.
Selective imports won't change compilation speed because it has to parse the module to find the import to select. So you're parsing it anyway. Selective imports won't do anything about speed. It just adds another symbol that is a direct link to a particular symbol.
All right, and with that, question time is over. So thank you